Hello, Mr. Gaza here, Rock Review 112. Hopefully you have done this and you're just checking your answers. I'll go through it in detail. Here we go. This one, we're going to use this picture of the rock here for the first two questions. Key thing is that it says here, the picture sometimes doesn't make it that clear, but it represents a rock composed of cemented pebbles and sand. That phrase in your head should tell you that it's a sedimentary rock. So, question one, this rock should be classified as, you need to get the, it should be 4, a clastic sedimentary rock. And the clastic means the pebbles and sand cemented together. Clastic means pieces of. Bioclastic means was once a living thing, so that would be something like coal, or it would be limestone with shells. So that is choice 4. Number 2. The key thing here is subject to intense heat and pressure, but did not melt. So we saw that partially melted. Fully melting would lead it to be an igneous rock, but the did not melt is key. And what would happen here is the pebbles would become distorted and the sand would be recrystallized. So that would basically be metaconglomerate with stretched pebbles. So that should also be 4. So more multiple choice. Here we go. Number 3. So it shows a large outcrop. Now this picture doesn't photocopy very well, and that's okay, because what it tells you here, it tells you visible crystals of microquartz and feldspar, and then it says it has foliated texture. So you want to go to your reference table, and I guess you have to realize that the foliated texture is going to be metamorphic. So you want to have the mica, quartz, and feldspar. So it's going to be mica, quartz, feldspar, and it has a foliated texture. So foliated is all of these. So it could pretty much be phyllite, schist, or gneiss, because those contain those minerals. Let's see what choices we have here. And that is going to be, see, number 2, schist. None of those others are in that one of your choices. So, and then this one. So the picture here also may not be very easy to see, but it does say it's light-colored igneous rock cross-cut by dark-colored igneous rock. This fine-grained, dark-colored igneous rock is most likely. Well, you have 4 choices. It's really only going to be one of those, so you want to realize this. Igneous rocks, this is the color. This is all the darker igneous rocks because they're made up of darker minerals. So it's going to be one of these rocks here, and you want fine-grained right there. So it's going to be one of these here. Is one of these a choice? And the answer is yes, basalt, choice 3. Right there. Okay, let's keep going. Now we're on to 5. So you got to read all of this here. Dashed lines not overturned. The granite formation was primarily formed by. So you could realize that granite, if you don't recognize granite, look around for it on the rock charts. You would find it right here. It's an igneous rock. Now once you know that, you should be able to put together the idea of knowing how igneous rocks formed. It should be choice 2, solidification of a felsic magma. And felsic magma is on the left side of the chart, high in silicon and aluminum. So that is choice 2. Number 6, if the Vishnu schist is to greater heat and pressure, it could have formed what? So it's schist is the kind of rock, but if it was under more heat and pressure, you have to go to the metamorphic rock chart. It's not something you know out of your head. And basically it says this is increasing heat and pressure. Okay, so as you go down these 4, you get more and more strongly metamorphosed. So schist, if it was under higher heat, higher pressure, it would become gneiss. So that should be a choice, and that is choice 1. Okay, number 7. So read all this. I'm trying to save some time here. So large amounts of dissolved calcite were carried by the river. Identify the sedimentary rock composed only of calcite that most likely forms. So what you have is go back to your sedimentary rock chart. Again, not something anyone expects you to have in your head. Use the chart. Composed of limestone. So that's where you want to go. Composed of calcite. I just gave the answer. Calcite right here. And the answer is limestone. And really, the answer is only limestone. That's not going to be anything else. Limestone. So hopefully you're seeing sort of what you need to know in your head and where to look things up. And that's what makes this tricky in general. 8 to 10. So always read this, and this one's saying base your answer on the passage, this diagram, and your knowledge of earth science. So be careful. This is not something where the answers have to come out of here. Oftentimes they don't, as we see in this case. So be careful. 8. What are the approximate crystal sizes in basalt and gabbro found in the drill core sample? So it's just a diagram there, but you want to get the crystal sizes. You need to go to the reference table, be able to recognize that those are igneous rocks, find them here, basalt and gabbro. So crystal sizes here, and you see your answer key has them listed with millimeters there. So basalt, you want to, it's that, and gabbro is this. So basically what you want is basalt is what I had for basalt was I had written this, less than 1, and gabbro 1 to 10 millimeters. Okay, so what I did here as well is I also got the key from the Regents exam as well to show you that this is what they had written on the answer key. So this gives you an idea of some acceptable responses. This is pretty straightforward, and this is what teachers have to follow when they grade it. So I'm going to add some of these in there. You could pause it because some of them are long to stop and look at, but that's for number 8. For number 9, what you have is describe how the mineral composition of dunite is different from the mineral composition of peridotite. So that's also something you need in the reference table. So you see, you need to really know what's in the reference table and what isn't. And you have to find peridotite and dunite and recognize that the mineral composition, as you go down, peridotite is really just pyroxene and olivine. Not asking you the percentages really, but you got to see that it's both of those. Dunite is all the way over here, and you see it's only olivine. So what I wrote originally on my answer key is I wrote this. I wrote some choices, 2 things I thought were reasonable answers. Dunite has no pyroxene. That's a good answer. Peridotite contains pyroxene. You could put that as a difference. And I also, this is what the Regents exam key was. It was this. Okay, so you could pause it here. Gives you some examples of some things that were in the key. So pause it if you'd like to read them. Okay, next one. 10. Which layer in the ophiolite drill core sample is composed of sediments? So you could say the clay layer or the clay with microscopic fossils layer. That's what I had written. And it's this right here. And that's just something that you kind of need to know. And for instance, I'll put the Regents answer key again up here. And what they have here for 10, it says allow one credit for clay or clay with microscopic fossils, or they took top layer as well. So interesting to see this. Be aware, some of these, this can be a lot to look at. And if it's confusing you and you got the right answer, don't worry too much about it. But they put a lot of wide variety of answers in there. But I just want to get everyone a sense of how this works. It will really help you in general as you go forward with all these kind of tests. Okay, what do we have? We're on the next page here. This video is end up being quite long, but that's just the way that it is sometimes. So next up here is this is a multiple choice. Most of the sediment that is compacted and later formed shale bedrock is this. Also reference table. Okay, so you got to realize, find shale if you need to. Realize that it is sedimentary rock. Shale is there, and most of the sediment. Okay, I guess what they need you to do is realize you got to go over here, and it is clay. So clay is the sediment, it makes shale, so that should be choice 1. Okay, 11 should be 1. And then on the bottom here you have, this diagram does not come out very well, but usually it's better on the Regents exam itself. But mineral percentage of a rock, so this is the mineral percentage here. Then these minerals here says identify 2 elements that are commonly found in all 3 minerals in the data table. Okay, so you got to look at those. What is common elements here? And you have to realize that this is now a mineral question. So you have to go to this page of the reference table, and we're looking at plagioclase feldspar, and biotite, okay, and amphibole, okay. And you got to recognize that the ones that are common are silicon, oxygen, or aluminum. Any 2 of those 3 works, okay? Any 2. All right. 13. Identify this igneous rock. So you got to do a few things here. The true scale crystal sizes of the rock. The original picture is a little easier to see, and this gives you a centimeter scale. These are actually, each little line is a millimeter here, so that's a little tricky. Realize some of the dark colored ones. Again, this did not copy that great. It was better in the exam itself. And with that composition, you have to realize and look at the igneous rocks chart, okay, and go plagioclase, feldspar, biotite, amphibole, and then follow it up to that crystal size between there and its diorite. I think it's a pretty challenging question. That's definitely a challenging question. And the Regents key said, you know, you got to put diorite. There's no half credit. It's just diorite's the only possible answer. Everything else would be wrong. So, and then 14 asked this question. Identify two processes that form the rock. So processes are often a problem for students, and a good thing for all the rock processes. These are the rock in the Earth's rock cycle chart. These labels of the arrows are all processes. Okay, so you always go here and look them up. Here we're looking for two processes, and the key thing is that this does say that this is igneous rock. So processes of igneous rock. What I had written was melting is a good one, solidification, cooling is another one, any two of those. And just to show you, what did the Regents suggest for that? The Regents exam key is said you could write any of these: melting, cooling, solidification or crystallization, hardening even. So they're making it more broad, and even heating. So the Regents says that you can accept all of those as answers. So we're going on here. What's 15 next? 15 is a multiple choice. Subject to intense heat and pressure, but did not solidify from magma. So you got to recognize that that is going to be a metamorphic rock. Okay, high heat, high pressure, but not from magma. And then you could just look at those choices and recognize which one of these. Go to your metamorphic rock. So it's up here really, and the best answer is going to be, the only one there is going to be schist. Okay, choice 2. 16. Which rock is limited that can be used for production of cement? So what you need to do, this is where it gets a little tricky. I would probably go through each one of these and then look at what minerals they're made of. And I guess what you need to do, you will realize, like, you'll end up on limestone. And limestone, as you'll see here, is composed of calcite. Then you got to go to, I guess, on the back of the reference tables, what they expect you to do is go to calcite and realize that this is the use there, cement. So that is a bit convoluted of how to get there. But the answer for that is choice 2 for 16. All right, 17, this one here, what does this say? Not been overturned. So what this shows, you always got to look at what this is. This is going to be igneous rock, so extrusive igneous rock. So this igneous rock went through these layers here. This represents contact metamorphism all along here and here. And that is where the igneous rock breaks through these existing layers, cuts through them, and it kind of cooks the rock here. And you're going to get contact metamorphism of these rocks. These type of questions are very common. 17 asks, identify the name of the contact at the boundary between the igneous rock and layer B. So igneous rock, layer B. This, you have to use your reference table chart, okay, and find that symbol. That symbol is sandstone. So the question is really, when sandstone gets metamorphosed by contact metamorphism, what rock can it become? Well, it's a metamorphic rock. And you got to kind of go down here and look, and this says metamorphism of quartz to sandstone, and that's what sandstone is. It's all quartz sandstone. So that's quartzite. That is the best answer, is quartzite here. Now, you will see that the Regents exam itself for 17, they also accepted hornfels as an answer, which is an acceptable answer, probably not the best answer, but again, acceptable, so it'll get you that credit for that question. And the reason is because hornfels is this sort of general rock that forms from contact metamorphism only, and a variety of rocks can change to it a variety of rocks can be the parent rock for hornfels. So that's also an acceptable answer, but quartzite is definitely the best answer. 18 is this one. Describe one piece of evidence that suggests that rock layer C formed in a deeper sea environment than rock layer A. This also may be a bit challenging. So A, you recognize, you look up the chart, that's conglomerate, and it's saying C for that symbol right there on the reference table under sedimentary rocks. That symbol is shale. Now this is the smallest sediment, clay, like the finest particles that make up mud. And this conglomerate here are the bigger pebbles, cobbles, and boulders. So the way that you can recognize that this formed deeper sea environment is that C has smaller sediments. You also can say that A has larger sediments, something like that. But what I had written when I first did this is C is composed of smaller sediments. That's how you know. And those smaller sediments get carried further out into the ocean, away from the shore, while the larger pebbles and larger grain sand from that make up A get deposited closer to shore. Let's see what the Regents had to say. The Regents exam had to say this. Okay, so you want to pause it right here. These are some acceptable answers. Okay. 19. Identify the mineral composition of rock layer D. Well, the answer is calcite, but how do you know that? So D, you have to look at that pattern. It looks like a brick wall, but in the world of sedimentary rocks, that symbol, you got to look up into page 7 of the reference table. That symbol is right here, okay? So that's limestone. Dolostone's when it's angled like that, but that's limestone. And the question is asking what mineral makes it up, and that's the mineral composition, calcite. So that is really about looking it up in the chart. Calcite is number 19. Okay, we're on to 20. So answer the questions based on the passage below and your knowledge of earth science. So not every answer usually comes out of here. Be careful. It's not one of those like a DBQ or something where you have to get the answer out of the reading. It's oftentimes not the case. So 20, explain why cyanide is classified as a plutonic igneous rock. So what I had originally written, I thought was a good answer, was cyanide has large crystals and coarse texture. So that's why it's a plutonic igneous rock. And let's see what the Regents exam had to say about this. The Regents exam key. And I encourage you to pause it. Note, see, this is key too. Do not allow credit for terms like texture or crystal or interlocking crystals alone, because they also describe volcanic igneous rock. So pause it, see some other examples here. Okay, next up, 21. It says, state one reason why anorthosite is likely to be white to gray in color. Well, what I did is it tells you here about anorthosite, and it says it's composed almost entirely of plagioclase feldspar. And then you go and look up plagioclase feldspar in the reference table, and it's that white to gray color. So I had written as an answer this. Anorthosite is almost all plagioclase feldspar, which is white to gray in color. So that's basically the idea. Let's look at what the answer key stated for that, which is 21. It says that. So pause it here. You can read these, compare your answers to that. Note this. Do not allow credit for that. So it's good to see the key and some things that kind of work as answers and don't work as answers. Let's 22. What this is asking, compared to the density and composition of granite, describe how the density and composition of gabbro are different. So the key thing, you are comparing granite to gabbro. So the density of gabbro, you have to look in the reference table, find them both. Okay, so what you're doing is the gabbro is here and the granite is right here. So the density, the only way to look is right here. On the chart, what it's saying is as you go this way, the rocks on this side of the chart, they're higher density a little bit, and as you go, the rocks on this side of the chart, they're lower density. So gabbro has higher density than granite. That's what the answer to this would be. Density of gabbro is higher. The composition of gabbro compared to granite, okay, that's the key. Don't just give the composition of gabbro. Compared to granite. Now, this is kind of a hard question. A lot of these are hard questions. So the composition, so you're talking about the minerals in it compared to granite. I know the first thing that I went to is that gabbro is more on this side of the chart, okay, so it is more mafic, you could say, that would work, and it is has more iron and magnesium. I also said that gabbro has less silicon and aluminum than granite does. So my set of answers look like this. My set of answers look like this here. So I wrote a higher for that one. I wrote more gabbro is more iron and magnesium than granite, or less silicon and aluminum than granite. The Regents exam, what it said was this basically. It said this right here. So you can write any of these, and it specifically says, and this is always key when you see this, do not allow credit if the student lists all the minerals in gabbro. Okay, because the question asks how the composition of gabbro is different from granite. So this is science, and usually you want to be pretty specific as opposed to being vague. So this is key to see this. So pause this if you need to compare your answers to those if necessary. Okay, and then 23, it says identify one dimension stone mentioned in the passage that is composed primarily of calcite. So primarily means kind of mainly of calcite. So the dimension stones are up here, and you have to kind of look through each one, I guess. Limestone, marble, sandstone, slate, and there's granite and gabbro as well. So composed primarily of calcite. So you have to go in the reference table. You're not going to know this out of your head, and you kind of have to look at all the mineral composition here and go through that chart. Now you see limestone here is composed of calcite. So that's one of them. Another one too you could have come across, marble is from the metamorphism of, oh, it says it has right here, calcite or dolomite. So that's true also. So your answer there could really be marble or limestone, and that's what I had originally written. And you just really need to have one of those. That's what's key. And as you can see on the Regents exam key itself, is it gives you really your answer. You have to write limestone or marble. Anything else won't work. So that's key. Okay, next page. These questions, as I'll say, these part 2 questions that we have here, they're quite challenging. So know that they're probably on the harder scale of the questions you get. So just know that. What it's here is asking you to draw 5 lines that connect the minerals that make up granite's composition. Okay, so here's granite, and you have to really look at the reference table. So see how much reference table is involved here to look these things up. So granite, the minerals in granite are these right here. Okay, so it's potassium, feldspar, quartz, plagioclase, biotite, and amphibole. So your answer should look something like this. And I'll show the answer key for the Regents exam is this. It's a solid line. So quartz has a line. These top 4 all have a line to granite, and then this has a line, which the dashed lines were already drawn for you. Those are kind of an example to show what it should look like. Next up is, let me see, the next question is 25. Describe one characteristic of the minerals in group A that makes them different from the minerals in group B. So you have to look here, the group A and the group B. Okay, so the best example, what did I originally write for that one? I wrote that the minerals in group A are lighter in color. That was the first thing that jumped out. I think most students will probably say that. But this is definitely a challenging question, I think. Let's see what the Regents put as an answer key as proper answers for this. And what they put are things like, you can pause right here, and if you have any of these, you're good. Okay, 26. And then it actually tells you to look in the reference table. Based on the reference table, identify one other mineral found in some samples diorite not shown in diorite in the sample diagram. So what you have here, also a challenging question. These are the main 3 components of diorite, which is plagioclase, feldspar, amphibole, and biotite. So look here and find diorite. Now this is definitely a challenging question. So diorite's here. Now diorite that's a little more towards the left side of the chart, the felsic side of the chart, will have a little bit of quartz in it, if you can see that right there. Or if it's a little more mafic on this side of the chart, it will have a little bit of pyroxene there. So either one of those answers will work. As you can see in 26, so the Regents answer key says either quartz or pyroxene, which means one of those 2 answers would work. Anything else doesn't work. Okay. And let's go on to the bottom one here, 27. A sedimentary rock, same basic mineral composition as granite. Describe one observable characteristic of the sedimentary rock that is different from granite. So this is really going to come out of your head. What do you know about sedimentary rocks versus igneous rocks. And what I had originally written was just some possible answers. I wrote, the sedimentary rock will have cemented minerals. Sedimentary rock will not have or have no interlocking crystals, because igneous will. Sedimentary rock will have fragments or rounded fragments. Any one of those would work. Let's see a good example here is 27. You can pause it on here. Here's some examples that the Regents key gives you. Okay, around to the last page. Okay, so these are some multiple choice. So you got to use this chart. This is really about reading the chart. Please always read all of this, and yours may be a little hard to read on here, but basically it goes like this. Which rock is most likely to form directly from rock at a depth of 30 kilometers and temperature of 1,000 degrees Celsius? So this is really figuring out this chart. This is a chart we've never really seen before, and they do that. Like, how well can you figure this stuff out? So we have a depth of 30 kilometers. So the depth is over here, pressure's here. That makes it a little challenging. So it's somewhere here. And then what kind of temperature are we talking? 1,000 C. So 30 and 1,000 C is right about there, okay? So it says formation of magma and igneous rocks. Great, not a choice. You have to pick one of these. That is this igneous rock. This metamorphic, this is not going to be, this is going to be a volcanic igneous rock, scoria. So this is really deep depth here. So the answer is going to be 4 granite on that one. The answer is going to be 4 granite. 29. Which letter represents the environmental conditions to form gneiss? So, if you don't recognize it, gneiss, you're going to find what kind of rock it is. You will find that gneiss is a metamorphic rock, high grade metamorphic rock, heat and pressure. So, you got to kind of look around and recognize you're looking for metamorphic rocks. So this is sedimentary rocks, not A. This is contact metamorphism only, B. This is regional metamorphism, and D is igneous. So you got to recognize that these rocks here, these are all regional metamorphism, which means a big region of Earth is buried. Contact metamorphism is not, gneiss is not contact metamorphism. So it will have to be choice number 3 for that one. It has to be choice number 3 for that one. And that's 4. At what pressure and temperature is sand most likely to be back into sandstone? You have to recognize sandstone is sedimentary rock, and this is the only area where sedimentary rock is. And actually, you know what? It's just A, but A is not a choice. It's asking for temperature and pressure, and you have to figure out which one of those it is. And all these other depths, 2 and 2 works, but all these other ones are way too deep, so the answer should be 1. So that one is basically figuring out it's going to form there, and then reading the chart based on temperature and pressure. So that was quite a long video, but these questions are quite challenging. They were challenging, and hopefully it shows you how much going back and forth with the reference table there is, and how knowing the reference table is very important. So I'm Mr. Gazda for homework 112 Rocks Review. Thanks for watching.